This talk is part of my series on how to design, develop, and maintain reliable systems. So I spoke a bit ago about how queues help, and I strongly believe in the use of queues because with queues you can ensure that your underlying components do not get overwhelmed with load. And the first job of a system is to protect itself. And you can't control the load that's coming in, but you can't control the load you accept. But queues themselves can have problems. They can get too long. Your request rate might be variable, and your response rate might be variable as well. Let's talk about what you can do in each of those situations. I actually had that happen to me in one of the services I ran at AWS. S3 went down for a bit of time, and the queue started to build up. And unfortunately, that particular service, which had just launched, didn't handle it. And so even though S3 came back up in a relatively short period of time, this service was down for many hours. And the reason for that is that the front of the queue, where we were processing, was where everyone had already said they timed out and they reissued a request. And so you end up in this funny state where everyone's timing out and the requests you're processing are not the requests anyone's paying attention to. So that's pretty common. The answer to that is that once you're past what you can process, not only do you need to, limit what goes into the underlying system, you need to limit what goes into the queue. So you just give errors. The queue is also a system that needs to be in its own way protected. Another thing that can happen is that you had a little bit of variability. Let's stay with that 1 second system. Let's say at one point you got 2 requests per second. Now the queue's always got one item in it. And so the response time is 1 second to wait for the queue to drain for my request to be handled, and then 1 second for the request itself. Now that's a lot. So how do you deal with that? So what I've done in the past is I basically build a feedback control loop around the queue length. And what I'm basically trying to do is understand how long does it take for the request to get processed, because that can change over time. What's my request rate going in? And my control is how many requests I fail. And that's basically based on how long are people spending in the queue. So my assumption is that the people who are calling me are probably also code, and they are going to time out after 2 to 3 times the normal duration. And so if I ensure that the queue time is no more than, let's say, the same amount of time as the response time, it works out. So that's another reasonable trick that you can apply. And the third one that I'd suggest to you is that what do you do when you have a lot of variable request durations? So, for example, if in a database it takes longer, no surprise, to process 1 billion rows than 1,000 rows. But, the requests look much the same. The trick I've done in the past is you can't rely on the query optimizer for this because you're already in this underlying system. You need to do this stuff before you go in. And what I found, though, is that you can apply some lightweight machine learning and just estimate costs outside the queue. It's almost like you're at the grocery store and you're trying to decide whether someone's allowed to go into the 7 items or less lane or they're going into the regular lane. And because, it'll get processed faster if they've got less work to do. And a second of queue time matters less for a 1-hour query than it does for a 10 millisecond query. And so, you're basically trying to bin these things and, prioritize accordingly. To maximize throughput. And that actually can pretty easily be learned because you can do a prediction, and then if it's wrong, you can roll that back into your machine learning algorithm. So it works surprisingly well. So those are 3 suggestions on how to fix the problems of queue buildup.